Hey everyone, welcome back. Today I'll be going through Module 2 of the InsideSherpa Quantium Data Analytics Virtual Experience program. This is part 2 of a two-part series. So if you haven't already watched the first part, I would recommend you go watch that first and then come back to this video. So recall that in task 1, we did some simple exploratory data analysis, also known as EDA, over our dataset, and we managed to pull out some insights about our customers and their purchasing behavior of chips. So for task 2 today, we're going to extend that analysis a little bit further. So task 2 is called Experimentation and Uplift testing. We're going to extend analysis from task 1 to help us identify benchmark stores that will allow us to test the impact of trial store layouts on customer sales. So similar to Module 1, you can visit the InsideSherpa website. That's where you'll find the information to Module 2, as well as some instructions that you'll need to complete this module. On that page, you'll also find the data that we're going to use throughout this module, as well as a solution template. All right, so for the sake of keeping this video short, I'm just going to give you an overview and a summary of what exactly we're dealing with in this module. So similar to Module 1, we're working with Julia, who works as a category manager at a particular retail store, and she looks after the chips category. And she's come to us saying that she's made some store layout changes to 3 particular retail stores, and they are stores 77, stores 86, store 86, and store 88 over the months going from February to April, so 3 months. And she wants us to assess whether or not these changes in store layouts have resulted in positive outcomes for the retail store, meaning have we seen any improvements in terms of total sales or number of customers, etc. So that's what we're dealing with in terms of this module. So without further ado, let's just move on to the notebook itself. So the first cell is just the libraries that we're going to use throughout this notebook. I'm not going to go through in too much detail because it's very similar to our first module. So we're going to use pandas, numpy, seaborn, matplotlib. Missing number, statistics-wise, we have standard deviation and t, which stands for t distributions, and we have dates, as well as we're gonna remove all the warnings. Next, what we're going to do is just we're going to go ahead and import the data, and I've labeled my data frame as just data. And let's look at the first 5 rows. So if you've already gone through the first modules, this should look very similar. So going from the left, we have loyalty card number, date, store number, transaction ID, product number, product name, product quantity, total sales, pack size, the brand of the chips, live stage, as well as premium customers. In terms of the shape of the data frame, we have about 264,000 rows and 12 columns. And next one, what I like to do is use one of my favorite functions on Python, which is missing no dot matrix, just to have a look at, just to see if there's any null values present in our data frame. And judging from this diagram, we don't have any missing values. So moving on to this next section of the notebook, I've titled this next section as Select Control Stores. So what we're going to do is we're going to assign a control store to every single trial store. And the rationale behind that is we want to have an apple-to-apple comparison, meaning we want to look for stores that have similar attributes to the trial stores prior to the trial period. That way we can accurately look at whether or not that trial period has resulted in an improvement in sales or customers. So that's what we're going to do. So in this first cell, I have created a new column called year month, which essentially just takes out the year and the month out of the date column. And next, I've created 5 metrics that I want to use to select my control stores. And those 5 metrics are total sales, number of customers, transaction per customer, chips per transaction, and average price per unit. This is just what I've come up with, but if you have any other metrics that you have in mind that you want to use in your analysis, feel free to do it. But this is what I've come up with to help me select my control stores. So I'm not going to go through in too much detail on how I calculate them. It should be pretty straightforward. Like, say, for example, total sales is just the sum of total sales. Monthly store number of customers is just the unique loyalty card number for each store in every single month, and so on. So what I did is just created a data frame for all the 5 metrics, and at the end concatenate them together, meaning combine them together as one. And I've labeled this new combined data frame as measure over time, as you can see here. And then I went on ahead and renamed the data frame. So if we do row by row, each row corresponds to a store number and its performance in that single month. So say, for example, the first row is store number 1, and that And in the month of July in 2018, it has this number of total sales, this number of total customers, and so on. And what I did here next is I want to remove the stores that have incomplete observation periods, meaning we don't want stores that have no sales in any single month. We only want to look at stores that have sales going from um, July 2018 all the way through June 2019. That's what we call a full observation period. So the way I do that is I use a function in Pandas called pivot table. And for each row is a store number, and going across the columns we have July 2018 all the way through June 2019. And if we sum up the null values of each column, this should tell us the number of missing values in each month. So say for example, in this first row we can see that 2018 July we have 6 stores with missing values, 9, 8, and so on. So a better way to see this is to use the missing node.matrix function again. So this give a better visualization of what is going on. So let's just recall, so going from rows, we have store number 1 all the way down to store 272. So rows here correspond to store number and columns correspond to month. So if we can see here, this particular retail store has, this month, July is missing, August missing, September's missing, this is November, and so on. So another way you can do this is you can count the pointy things on the right hand side, and that should tell you the number of stores that have missing incomplete observation periods, meaning they have at least 1 month of null values. And if you count them, it should give you 12. And what I've done here is I've created a list of the trial stores that we want to eliminate and we want to take out because they have incomplete observation periods. And if we work out the length, so the length of this this list, they should give you 12. And what I did is go on ahead and drop this from our data frame, measure over time, which is in this cell. And then I've created a new data frame called pre-trial measures. We want to filter our measure over time into periods that is prior to our trial period, meaning anything that's before 2019 February. So this is what I've done here, and I've labeled this new data frame as pre-trial measures. So this is what pre-trial measures looks like. So it should have the store number, the year month, which is anything that's less than 2019 February, and the remaining 5 columns are just the matrix that I've established early on. These next 2 cells are functions that I've created. This is in order for me to calculate the correlation as well as the magnitude distance between trial store and the rest of the stores in that data frame. So I'm not going to go through in too much detail, but the first function is called calculate correlation, which takes in 3 arguments. So the first argument that we're going to pass in is the data frame itself. And then we're going to pass in the metric, meaning which metric we want to evaluate. It could be either one of these 5. So it could be total sales, number of customers, number of trades per customer, number of transaction per transaction, and average price per unit. And last but not least, we have the trial store that we want to compare with against the rest of the stores. So that's what calculate correlation does. It just calculates the correlation. Next function is very similar, so it will take in 3 arguments: the data frame, the metric of interest, as well as the trial stores, and I've labeled that as calculate magnitude distance. All right, so now that we have most of our stuff set up, let's just go ahead and actually select the control store for the first trial store, which is trial store 77. So first we want to compute the correlation with trial store 77. So we're going to go ahead and use the function that we've created above here called calculate correlation, as well as the function calculate magnitude distance. So recall that we need to pass in 3 arguments. So the first one is the data frame itself, and then the metrics is total sales, as well as the number of customers. So we're going to do that for trial store 77. And this is what we have in terms of correlation. So store 1, notice store 1 is all trial stores, and store 2 is the comparison store. So meaning this first row is the comparison between store 77 and store number 1, and this is the number of, this is the correlation. This is the same thing for magnitude. And then what I've done is I've concatenated both of these data frames together, and I've assigned a correlation weight, meaning I want to take a weighted average between the correlation and magnitude. I've set my correlation weight to be 0.5, but if you think that correlation, or either one of correlation or magnitude has a higher weight towards your analysis, you can easily change this up. And then we're going to do the same thing to number of customers. So this one looks at sales. This next bit is looking at number of customers. So just doing the same thing again, and then we're going to take the weighted average. But for us, it's just the average, which is 0.5. All right, and then what I did here next is just took this column, so this last column called score and sales, as well as score and cus, and I've concatenated them together. So we have our trial store in this first column, and then the second column is just all the other stores and their corresponding score and sales, as well as score and cus. And what I've done next is create another column called final control score, which computes the average of score and sales and score and cus. Take this number plus this number divided by 2. That should give you this number. And we're going to do that for all the store comparisons, going from trial store 77 versus store 1, 77, 2, 77, 3, and so on. All right. So now that we have that final control score, we're going to go ahead and ascend from highest to lowest. So as we can see here, the highest score belongs to store number 233. So we're going to assign that as our control store. So now that we've determined this is our control store, let's just do some visualization to make sure that that is actually the case. So I'm not going to go through this in too much detail. What I've done is prepare a data frame that we're going to use for our plotting. So I've created a new column called store type, which labels stores 77 as trial store, store 233 as control stores, and the other stores as just other stores. So you can go through this yourself. I'm not going to go through it. And then I went on ahead and created a new column called transaction month. Again, this is for plotting purposes. So this next part, I create a total sales visualization for control store, trial stores, and other stores. So this is the data frame that we're going to use to plot. So if we do our plotting, we get something that looks like this. So the green up here represents the other stores. And what we're most interested in is the comparison between our trial store and control stores. So we should expect them to have kind of a similar pattern, meaning they're correlated to each other. So if we look closely here, it's almost doing the same thing, right? So we have the blue one going down and then kind of come up in the month of October, which is the same thing with the orange line. So it's kind of coming down here and then coming up, and then we have a slight drop here in the December month. Right, so we're going to do the exact same thing to number of customers. I'm not going to go through it, so it's just this exact same thing. We're going to create a new data frame, and then we're going to use that data frame to plot a visualization. All right, so this visualization looks even better. So we can see here that it's almost, both lines are almost identical to each other. So it's, it's coming down and then popping up again in the month of October, and then comes to December, it comes back down. Look how both lines are almost overlaying each other. So that's a very good sign that we've come up with the right control store. All right, now that we've established store number 233 as our control store for trial store number 77, we can now proceed with the actual assessment. So we want to see whether or not this trial period has successfully contributed to a high number of sales and high number of customers. All right. So what we're going to do first is compute something called scaling factor sales. So the way you do that is you sum up total sales for a trial store, and then sum up the total sales for control store, and then you're going to take that trial sum and divide that with the control sum. And then what I did next is again create a new data frame called scale control stores, and then multiply the total sales in scale control stores with the scaling factor that we just computed. And then what we're going to do is we're going to create a new column called percentage diff, which takes the percentage difference between the scale sales for control store as well as the total sales for trial stores. And the way you do that is you take the absolute difference between this column, absolute difference between this column and this column, and then you divide it by this column. And then I've just put all of that into a new column called percentage diff. And what we're going to do next is take the standard deviation of this column, and we only want the year month that is less than 2019 February, meaning we only want months that are prior to the trial period. And then what we're going to do is just go ahead and define the degrees of freedom. So if you're familiar with T distribution, the degrees of freedom should be the number of samples minus 1, so n minus 1. So for us, n is 8. We have 8 samples, and we're going to minus 1. So degrees of freedom here should be 7. And in next cell, I worked out the T value for February, March, and April. So these are the corresponding T values. And then what I did here is look at the 95th percentile for the T distribution for degrees of freedom of 7. So a T distribution should look very similar to a normal distribution. So what I've done here is I worked out the 95% percentile. So I worked out what the number here is. And any number that is higher than this number, we can conclude that there is a significant difference in percentage diff. So as we can see here, the 95th percentile is about 1.89. All right. And then what I did next is create a new column called transaction month. So the reason why I created transaction month is for plotting purposes. So if you were to have a go at the plotting yourself, you'll realize that you have to do something like this in order for the plotting to work. And what I did here next, you can just go through it. So essentially, I'm creating a new data frame which contains the scale control sales and the 5% confidence interval. And the way you do that is you multiply 1 minus standard deviation times 2. And for 95%, you do multiply by 1 plus standard deviation times 2. So this is the 5% confidence interval on this number. This is the 95% confidence for this number. And then combine that with the trial sales. So now we have our complete data frame for our plotting. So what I did next is just plot. So this doesn't look good at all, and it's hard for us to analyze anything. So what I've done next is just embellish the plot. So first make it big, make it look bigger, and then set my titles and set my graph title and axis title, set the legend, set my Y limit, as well as highlight the trial period that is between February and April. And so this is what we have. So as we can see here, the blue represents the control sales, the green and the yellow. So the green is the 95%, and the yellow is the 5%. So what we should observe is the red line that is in this region. So in this region that I've highlighted is the trial period. So we can see that for months of, so this is March, for the months of March and April, it's significantly higher. So it falls outside of the 95% confidence interval, whereas for February, it is within that confidence interval. So I've left a little comment here saying that the results show that the trial in store 77 is significantly higher to control store for the months of March and April, which is 2 out of the 3 trial months, which we can conclude that it's we see a significant improvement in terms of sales. So we're gonna replicate that analysis on number of customers. So we're just gonna do the exact same thing, but we're gonna move on to a different metric, which is number of customers. So essentially here, I'm just gonna skip through it because we're just doing the same thing. And then finding the standard deviation, looking at the T value, and then create the data frame. You can do all this yourself. You can go through it in my notebook, so I'm not gonna go through it. So you should arrive at something like this. So this is the final data frame that we're going to use for our plotting. And eventually, once you do the plotting itself, you should get something that looks like this. So it's very similar to in terms of sales. So we have for the month of March and April, it's significantly higher, whereas for the month of February, it falls within the confidence interval. All right, so we can conclude that for trial store 77, it's quite significant in terms of the trial period, and it has resulted in improvements, especially for the months of March and April. So we can say that, judging from the results for this particular trial store, this change in store layouts have resulted in some substantial improvements. So the next part, I'm not going to go through it. It's essentially just a repeat. We're going to move on to the next trial store, which is 86, and for the last part is 88. So you're just doing the exact same thing. And yeah, so that should conclude module 2. Alright, and that concludes the series on InsideSherpa Quantium Data Analytics Virtual Experience Program. I hope you gained some value out of both this video as well as the video prior to this. I'm not going to go through module 3 because that is just simply a consolidation of your analysis both from module 1 as well as module 2, and putting that into a slide deck, and then you can submit that. So I'm not going to go through that. I was thinking of making a pandas tutorial. So I'll walk through every single week. I'll walk through a particular pandas feature. That way you guys can learn about pandas in more detail. Next time I release a walkthrough or a tutorial on a specific project, it's easier for you guys to follow along. So let me know if that idea appeals to you at all. And feel free to reach out to me, send me a message, let me know where I can improve. But otherwise, I'll see you in the next video. All right, take care.
1, 2, 3, 4. Started off right, I can see it in your eyes, and I know that you want it more. What's been on your mind? There's no reason we should hide. Tell me something I ain't heard before.